Hello and welcome to this online lecture about mole ratio and reaction stoichiometry. The purpose of this lecture is for you to be able to calculate, if given an amount of reactants, the amount of products that will form after a reaction, or if given an amount of product that's needed, the amount of reactant that needs to react. So because this is about reactions, we're going to have a reaction to talk about. We're going to use the reaction of aluminum with oxygen to form aluminum oxide. And we have to balance this equation. So we'll put a 2, and a 3, and a 4. Alright, so the first thing we're going to talk about is mole ratio. And mole ratio is the ratio of, it's basically the ratio of the number of molecules of one thing in the reaction to another thing in the reaction. And we find the mole ratio using the coefficients. So the mole ratio comes from the coefficients. And it's really important that you can find the mole ratio between two compounds because you're going to use that as a conversion factor when you do reaction stoichiometry. So let's say we wanted the mole ratio between aluminum and aluminum oxide. That mole ratio is 4 to 2, which reduces to 2 to 1. And let's say we wanted the mole ratio between oxygen and aluminum. That mole ratio is 3 to 4. So this is called mole ratio. And it's really, really important to reaction stoichiometry. You have to be able to find the mole ratio between two substances. Okay, so let's say, now that we've covered mole ratio and how to find that, I'm going to show you how you can convert between an amount of reactant to an amount of product. So let's say that given this reaction, I don't know, let's just say 30 moles of oxygen are going to react. And we want to know how many moles of aluminum oxide that's going to make. So here's how this works. We're going from basically moles of one substance to moles of a different substance. So the unit doesn't change, but the substance does change. So you're going to start, as always, with what you're given, and you are given 30 moles of oxygen. And then you always put the same unit and substance down here to cancel. So we're going to go moles of oxygen. So it's the same as what we were given. And then in this problem we want moles of aluminum oxide. So we're going to put moles of aluminum oxide. Alright. So what we've done is we've set up our dimensional analysis for this problem right here, this simple reaction stoichiometry problem. And when we solve that, it's going to give us the number of moles of aluminum oxide. Now, if you look at this, you'll see that you got moles over moles. Well, what you have here is the amount of moles of one of these substances in this reaction compared to moles of one of the other substances in the reaction. And this is where the mole ratio comes in. The mole ratio that we just talked about. So we need the mole ratio between aluminum oxide and oxygen. So we're going to look up at our equation. We're going to look up here, and aluminum oxide's coefficient is 2. So we're going to put a 2 with the aluminum oxide. And oxygen's coefficient is 3. So we're going to put a 3 with the oxygen. You see how that works? And this is the mole ratio between aluminum oxide and oxygen. It's 2 to 3. And then, as you always do with dimensional analysis, we're going to multiply by numbers on the top, and we're going to divide by numbers on the bottom. So 30 divided by 3 is 10, times 2 is 20. So the answer to this problem is 20. And let's see, some stuff cancels out here. Moles cancels, and oxygen cancels. So we're left with 20 moles of aluminum oxide. And that is the final answer to that stoichiometry problem. And that is also how you use the mole ratio to convert from moles of one substance to moles of another when you're doing reaction stoichiometry. Now, that's all well and good, but if you remember from before when we were talking about stoichiometry, you can't really measure moles in the lab. but you can measure grams. So what we need to look at is, how do we go from grams of one substance to grams of another? Now we're going to use the same equation. I'm just going to go ahead and copy it. We're going to use the same equation and reaction here. So let's come down here. Hopefully this works. Did that copy? Let's see. Edit. Okay. So we're going to come on down here, and I'll throw that equation back in there. There it is. I'm just going to put it right up here. And this time, instead of going from moles to moles, we can't really measure moles. So let's say that we had, let's say we had 20 grams of aluminum. And we want to know how many moles of aluminum oxide that's going to make. Now you'll notice the difference in these two problems is that in the first problem we were given an amount in moles and we were asked to find an amount in moles. But in this problem we're given an amount in grams and we're asked to find an amount in moles. So here's the problem. You can't go from grams of one substance, like grams of Al, you can't go straight to moles of another substance. So basically think about it like this. You can convert a unit in one step, or if you're in moles, you can convert the substance in one step. But you can't do both in one step. And so you can't do this. Can't do that. So basically this stoichiometry problem is going to take two conversion factors. Let's set it up and see what two conversion factors that is. So we've got 20 grams of aluminum from our problem up here. And I'm going to put grams of aluminum down here so that it cancels. And we want moles of aluminum oxide. Well, if you know the moles of one substance, then you can convert to the moles of another substance using the mole ratio. But we don't have moles of our first substance. But we can find moles of our first substance. So we're going to go from grams of aluminum to moles of aluminum. And whenever you're in moles, you can convert from one substance to the other. So then after we're in moles, we're going to go from moles of aluminum to moles of aluminum oxide, which is what this problem is asking us to find. So now we have two conversion factors. This one we just talked about. That's the mole ratio, and you get that from the balanced equation, from the coefficients. And this one you have seen before, and if you need to go back and look at that online lecture, you're more than welcome to. But this is the molar mass, and it comes from the periodic table. Right. So let's find the molar mass of aluminum. We need to look at the periodic table. Let me turn that on real quick. And aluminum's right here, and it looks like to two decimal places our molar mass is 26.98. 26.98. So that's 20, whoops, let me get my pencil back, there we go. 26.98 grams in 1 mole of aluminum. And then we need this conversion factor, which is the mole ratio, and that comes from the balanced chemical equation. So we have aluminum oxide and aluminum. So aluminum oxide's coefficient is 2, and aluminum's coefficient is 4. And now to solve this problem, we're going to take 20, divide by 26.98, multiply by 2, and divide by 4. Let me pull up my calculator, and we can go through that. All right, here's my calculator. So 20 divided by 26.98 times 2 divided by 4. And that equals, let's see, 0.37. So 0.37 what? Well, the grams of aluminum cancels, the moles of aluminum cancels, and the unit that we're left with is moles of aluminum oxide. And so we've went from grams of one substance to moles of another. And then there's a third possibility, and that is you are given grams of one of the substances and you need to calculate grams of the other substance. So let me scroll down here yet again. I wonder if I can just No. So let me grab our equation again here real quick. So grab that. Okay. So basically, it would look like this. You'd say, let's say, oh, for this one, let's kind of switch it around a little bit, and we'll give you a reactant amount. So let's say we needed to make 100 grams of aluminum oxide, and we wanted to know how many grams of aluminum were required to make that much. So we're given an amount in grams, and we're trying to find an amount in grams. So let's see what we're going to need for this here. So 100 grams of aluminum oxide, right? So we're going to have to go from grams of aluminum oxide, 2 there, to moles of aluminum oxide. And we have to go to moles so that we can go from moles of aluminum oxide to moles of aluminum. But the problem doesn't stop there because it's asking us to find grams of aluminum. So we're going to go from moles of aluminum to grams of aluminum. So let's see what kind of conversion factors we need here. This is grams per mole, so that's a molar mass. You find that in the periodic table. This is moles per mole, so that's a mole ratio, and you get that from the balanced equation. And this is grams per mole, so again, that's a molar mass, and you're going to find that on the periodic table. All right, so let's solve this. We're going to bring our calculator back in here, and we're going to find our molar masses here. So we've got to find the molar mass of aluminum oxide, and that's going to take a little bit of calculating. Let's bring our periodic table back. Let's scroll back up there, and now we've got to bring our calculator back. So aluminum oxide is 2 aluminums and 3 oxygens. So we have, in parentheses, 2 times aluminum, which is 26.98. Whoops. So 2 times 26, stop, 26.98. And then we're going to add that to 3 times oxygen, which is 16. And so 101.96 is the molar mass of aluminum oxide. So we'll scroll this, 101.96. We'll bring our problem back here, and sorry about that, 101.96 grams per mole. The mole ratio for aluminum is 4, aluminum oxide is 2, so it's 4 to 2. And then grams of aluminum, we just have to get it off the periodic table. We were just looking at that, and so it's aluminum is 26.98. So take that back away. 26.98. Perfect. So we're going to take 100, we're going to divide it by 101.96 times 4 divided by 2 times 26.98, and we're going to need the calculator again to do that. So 100 divided by 101.96 times 4 divided by 2 times 26.98 equals, and so we get 52.92. So equals 52.92 what? Well, grams of aluminum cancels, moles of aluminum cancels, or moles of aluminum oxide cancels, moles of aluminum cancels, and you get grams of aluminum. So that concludes this lesson. As always, if you have any questions, feel free to ask in class, and thank you for watching.